Hello, everybody. We are going to learn our next type of factoring today, and that is simple trinomial factoring. So we're going to learn how to factor simple trinomials, understand why it's useful, and then interpret the results within a word problem. So first things first, let's understand what a simple trinomial is. So a trinomial has three terms. A simple trinomial has a coefficient of 1 on the x squared. So instead of thinking about it as ax squared plus bx plus c, it's really just x squared plus bx plus c because our a value is 1. Our coefficient on x is 1. So before we learn how to factor them, let's first go back and remember how to expand to a simple trinomial. So again, this is something that is in factored form, and we want to put it into standard form. Factoring is going to allow us to go the opposite way, okay? But looking at how this relationship works will help you understand why factoring works the way it does. So let's FOIL this out. So you get x squared plus 7x plus x plus 7. So our final is x squared plus 8x plus 7. So let's take a look at the two numbers that we have, the two coefficients. We have an 8 and a 7. How are they related to the 1 and the 7? What can you do with the numbers 1 and 7 to get 8? What can you do with the numbers 1 and 7 to get 7? Hopefully you can recognize that 8 is just 1 plus 7, and 7 is 1 times 7. So you add these two numbers together to get the coefficient on x, and you multiply the two numbers together to get the final constant. Let's see if this relationship holds true when we just let our numbers be r and s. So when we FOIL this, you get x squared plus sx plus rx plus rs. Remember that s and r are numbers and x is our variable. So if we were to collect like terms, think about it. When you collect like terms, you add the coefficients to get your new coefficient. So you add 7 plus 1 to get 8. So here you would add s plus r to get your coefficient on x, and then you get the number rs. So this would just be a number. So here, this would be a number, and this would be another one number. So notice that the coefficient on x is just the two numbers here added together. And the constant is just the two numbers multiplied together. So this was a specific case where we showed that. This is the general case, which proves it. Therefore, we want to find two numbers that add to the middle number, which we call b, and multiply to the constant, which we call c. We can verify our answer by then FOILing. So FOIL and collect like terms. So we're going to use this fact now to go in the other direction. So where we're given the trinomial and we need to come up with the two binomials. So let's look at the numbers here. So our b value is 12 and our c value is 27. So we want to think of two numbers that multiply to 27 and add to 12. If we can do that, then we will be able to factor. So they have to be the same two numbers. So lots of different numbers add to 12. 1 and 11, 2 and 10, 3 and 9. So going through the different options for adding to 12 first doesn't really make sense. Only a very few sets of numbers multiply to 27. Those would be 1 times 27, 3 times 9, and then -1 times -27, and -3 times -9. So your job is to think, are there any of these that also add to 12? Well, 1 and 27 doesn't, but notice that yes, 3 plus 9 adds to 12. Therefore, the numbers are 3 and 9. 3 times 9 is 27, and 3 plus 9 is 12. So that fits the factoring pattern. So we can factor this to x plus 3, x plus 9. All right, so let's verify by using FOIL. That's all the work you have to do, but now I'm just going to show you why this works. So if we FOIL this out, we get x squared plus 9x plus 3x plus 27, which simplifies to x squared plus 12x plus 27. So we know we did it right. This and this are just two forms that mean the exact same thing. Let's try it again. In this case, we have a b value of 7 and a c value of 12. So we need two numbers that multiply to 12 and the same two numbers that have to add to 7. So again, it's simpler to start with the multipliers of 12 first. So 1 and 12, that doesn't add to 7. 2 and 6, that does not add to 7. 3 and 4, that does add to 7. Okay, so 3 and 4 multiply to 12, and they also add to 7. So therefore, our answer is 3x plus 3, x plus 4. Now, notice you could also do x plus 4 times x plus 3. The order doesn't matter. Okay, and again, you could FOIL to show that it is correct because you would get back to the original. Okay, here's an opportunity for you to practice. Okay, so I want to have you practice this one and then come back to the video. Okay, hopefully you got x plus 2 and x plus 3. 2 and 3 add to 5, and 2 times 3 multiply to 6. Okay, let's do this one together. It's a little bit more complicated when there's negatives and positives in the same one. Okay, so here it has to multiply to 28 and add to negative 29. And you might think, well, how does this work? Well, if two numbers multiply together and the result is positive, but when you add them together, the result is negative, both of those numbers must be negative. Think about that for a second. The only way for you to get two numbers that add to a negative is if at least one of those two numbers is negative. However, for them to multiply to a positive, they must both be negative to get a positive result. So the answer here is negative 28 and negative 1. That multiplies to positive 28 and adds to negative 29. So it's x minus 28, x minus 1. Okay, here you have where the adds to a positive but multiplies to a negative. Okay, so we need to multiply to negative 18 and add to positive 3. So because they multiply to a negative number, one number must be positive and one number must be negative. Okay, so then they have to add to 3, which means the larger number would be positive, so that the net result of the addition is still positive. So let's think about what multiplies to 18. So 1 and 18, that doesn't work. 2 and 9, that doesn't work. 3 and 6, yes, 6 and negative 3 works. 6 times negative 3 is negative 18, and 6 plus negative 3, so 6 minus 3 is 3. So you have x plus 6, x minus 3. Here they are both negative, so they multiply to negative 21, and they add to negative 4. Again, this means one must be positive, one negative, but the larger one is negative. so that it results in a sum that is negative. So again, let's go through the choices. 1 and 21 doesn't work. 7 and 3 is the one that works. Okay, because it's 7 times negative 3, and then negative 7 plus 3. So x minus 7, x plus 3. Okay, so for these next ones, you have to remove a common factor first. Notice that they are not simple trinomials because they have an a value that is not 1. But you'll notice that in both cases, that a value can be factored out. So in this case, the common factor is 3. So you can take it out and you get x squared plus 4x plus 3. Now, inside here is a simple trinomial that we can factor. Two numbers that multiply to 3 and add to 4. So we leave the 3 out here, and we conclude that it's x plus 3, x plus 1. Just note that a 3 is part of the factoring. You common factored and then used simple trinomial factoring. So this was a common factor, and then we use simple trinomial. So 2 types of factoring were used, but you need both of them. This is the final answer, the fully factored answer. Here, notice that you can factor out 5x. And then you're left with x squared plus 7x plus 10. Okay, so now this is your simple trinomial, which can be further factored. So the 5x is still part of the solution, but then this can be factored to x plus 5, x plus 2, because 5 and 2 add to 7 and multiply to 10. Let's do a new type of example here, where I'm just kind of looking ahead of how much we have. Okay. Where we are determining an unknown value of b that make a trinomial factorable. So not all trinomials are factorable. So in order for it to work, it has to fit the pattern. So notice in this case, our c value is 6. So that means the two numbers have to multiply to 6. We don't know what b is equal to, so we can make it whatever we want. So we just pick two numbers that multiply to 6. Let's just say 1 and 6. So that means b will just be equal to whatever they add to, which is 7. So that means a b value of 7, or a trinomial x squared plus 7x plus 6, is a factorable trinomial because you can find two numbers that multiply to 6 and add to 7. In b, we know what b is, which is negative 3, but we need to find a c that makes it factorable. Okay, so we just need to pick two numbers that add together to negative 3. So for example, we can pick negative 5 and positive 2. Okay, or you can pick negative 4 and positive 1. Anything you want. So that means our c value is just the product of those two numbers. In this case, negative 10. So a c value of negative 10 will make this factorable. The trinomial would be x squared minus 3x minus 10. Part number 2. Determine binomials that represent the dimensions of the rectangular water garden whose area is x squared plus 5x plus 6. So if our area is x squared plus 5x plus 6, that means we must have a length and a width that multiply to this. So in order to find out what those are, we need to factor, which undoes the multiplication. Okay, so we actually already factored this. It is x plus 2 and x plus 3. Okay, those two numbers add to 5 and multiply to 6. So then you can choose one to be the length and one to be the width. It doesn't really matter. So if x is equal to 1, you would have 1 plus 2, which is 3, and then 1 plus 3, which is 4. So that would work. Okay, last example. The equation of a quadratic is given by this equation. What is the optimal value? So to find the optimal value, that is the y value of the vertex. So notice that this is not in vertex form, so we can't find the vertex. what we are going to do is factor so that we can find the zeros. Then once we have the zeros, we can find the vertex and the optimal value. So you get y equals x squared plus x minus 42. So something that adds to 1, and multiplies to negative 42 is what we're looking for. So go through the different options of what multiplies to negative 42. Eventually you should get that 7 and negative 6 multiplied to negative 42 and add to positive 1. So the factored form is x plus 7, x minus 6. Okay, I challenge you to finish this example to actually find the optimal value. You already learned these skills in chapter 4. You've already been tested on them. So I want you to go ahead and I'll take this up in our next class. Find the zeros, then find the x value of the vertex, and then find the y value of the vertex, which is your optimal value. So as a result of this note, you should be able to recognize if something is a simple trinomial, factor it by finding two numbers that multiply to C and add to B, and finally, verify that your answer is correct using the FOIL method. Thanks for watching, guys, and I hope you learned lots.